All right, we're starting a new unit on inverse functions. A function is a relationship for which every input has exactly one output. So every time you put a number in, one number comes out. An example of that can be done here with a mapping, where we map one number to another number. For example, if we have 2, 5, and 7 in our domain, or these would represent x values in our domain, then y values might be just some random number like 8, 10, 25. And we could pair up each x value with one y value to make a point. The 2 might be mapped over to the 8, 5 goes over to the 10, 7 mapped over to 25. This is a function. Every element in the domain is mapped to one element in the range. We call that a function because there's exactly one output for every input. Let's see, let's do another one that's also a function. 2, 5, 7. So these first numbers are x values, and they are mapped to a y value. Let's say 3 and 9. If 2 goes over to 3, maybe 5 goes over to 3 also, and 7 goes over to 9. Each element in the first bubble goes over to only one number in the second bubble. So each number still has exactly one output, so this is a function. All right, now let's talk about one that's not a function. Let's use 2, 5, 8, 9, 10. All right, so let's say 2 goes over to 8, and also 2 goes to 9, and 5 maybe goes over to 10. This is not a function because 2 is actually going to two different outputs. Now we have two outputs instead of just one, so there's not one output. So this is not a function. All right, to find the inverse means we switch the domain and the range. This also can be done with switching the x and the y variables. If I had a set of points, to find the inverse of that set of points, I just reverse the order, switching the x and y. So the order of pairs become 3, 7, negative 11, 12, negative 8, 17, negative 16, 6. So we just switch the x's and the y's. If we see this is a table and we want to find the inverse, we just make another table here. And we've got our x's and our y's. We get the point 4, 2, 7, 3, 2, 6, 7, 5. Is this a function? Does 4 only go to one number? 7, 2, 7. Okay, so since 7 is going two different places, the inverse is not a function. The original 2, 3, 6, 5 is a function. So the original was a function, but when we did the inverse, it was not a function. Okay, over here on this next example, let's see if this is a function. 4. Does 4 go to two different places? Yep. So this is not a function to begin with. Not a function. The inverse, if we switch these x's and y's, let's see, we're going to get 3, 4, 7, 6, 2, 8, 9, 4, and 5, 5. Let's see. The 3 only goes to one number, 7, 2, 9, 5. So all the numbers in the x column are different for our table. So yes, this inverse is a function where the original was not. Okay, when we look at this as a graph, you can do the same thing. If you pick a point, right here, this a value, it's over 1 and up 3. So this point A is negative 1 comma 3. Its inverse point is going to be 3 comma negative 1. 3, negative 1. So here's the inverse. We might call that A prime. A prime is at 3 comma negative 1. Let's see, point E is 0 comma 2, 0 comma 2. So its inverse is going to be 2 comma 0. Call that E prime. Right, at 2 comma 0. The point F is negative 2, positive 2. Negative 2, positive 2. So its inverse will be positive 2, negative 2. So here's F prime. F prime is at 2 comma negative 2. So the inverse function is going to be going sideways. Just like that. So let's see. So is the original a function? Yes, it was a function to begin with. Is the inverse a function? Well, we'll talk about that here in just a minute. Let's see, on this next graph, we have this exponential function. Let's try to pick out just a few points. Maybe 3, negative 6, 3, negative 6. So its inverse will be negative 6 comma 3. Up here. 5, negative 3. Its inverse will be negative 3 comma 5. Maybe just one more to be accurate. 6 comma 1, which inverse would be 1 comma 6. All right, so we've got 3 points here, but another identifying feature of an exponential is the asymptote down here where it is flat. If I have a horizontal asymptote at y equals negative 7, then our inverse is going to have a vertical asymptote. So we have an asymptote. Right, asymptote would be this boundary line, this force field that the function approaches, gets really close to. So if the original had an asymptote at y equals negative 7, then the inverse will have an asymptote at x equals negative 7. And our inverse function will follow this asymptote up, hit our points. We'll have something like that. Okay. All right, the notation for inverse of f of x is represented with f with a little minus 1 up top of x. We call that f inverse of x. F with a little negative 1 in it. It looks like an exponent. It's not. It's just the notation for inverse. And you may find that on your calculator as well, that there may be an inverse button. F negative 1 of x is called f inverse of x. Okay, one-to-one function. A function for which every element of the domain corresponds to exactly one element of the range is called one-to-one. Often we write this 1-1 or 1-to-1. Okay, so one way we can identify whether or not something is a function is by the vertical line test. It's a quick visual way to determine whether something is going to have each element from the domain mapped to one element in the range is to draw a vertical line through the function, the graph of the function, and see if you hit two places. So with this parabola, if I come down with a vertical line, I'm only going to hit it one time. One time. One time. So it's going to pass the vertical line test. So it's a visual way to check to see whether or not a particular graph is going to represent a function. Same with this exponential over here. If I draw a vertical line, it only hits one time. This is a function. So both of these graphs are functions. So the vertical line test is a visual way to determine if a curve is a graph of a function or not. There is also a horizontal line test. If we draw a horizontal line through our function and it hits one time, then its inverse will be a function. Well, this parabola, when I draw a horizontal line through it, I'm hitting more than one time. So the inverse is not going to be a function. As we saw up above, the parabola, when it's sideways, won't pass the vertical line test. So the inverse is not a function for a parabola. And for the exponential graph, if I draw a horizontal line, it's going to only hit one time, only hits one time. So the inverse of an exponential would be a function. So the horizontal line test, if a horizontal line crosses the original function more than once, then the inverse is, is more than once, is not a function. So if you hit more than once, it is not, the inverse will not be a function. If the horizontal line only crosses once, it passes the horizontal line test, and the inverse is a function. Okay, how to identify a one-to-one function from a graph? If the graph passes the vertical and horizontal line test. Then the function is called one-to-one. Okay, let's talk domain and range. For inverses, the domain and range of an inverse will be related. The domain of our original function becomes the range of our inverse function. And the range of our original function becomes the domain of our inverse function. So let's do a couple of examples here. First, we have a parabola, a graph of a parabola, and we want to know if it passes the line test. Does it pass the vertical test? Yeah, it does. So a parabola is a function. Does it pass the horizontal line test? No. It fails the horizontal test. So the inverse is not a function because it fails or does not pass, we can say fails, the horizontal line test. Okay, this next graph would be probably the graph of the square root of x. It will pass the vertical line test. A vertical line will only hit one time. So the original is a function. Is the inverse a function? Well, a horizontal line is only going to hit it one time. Only one time. So the inverse is a function. And we know it's a function because it passes the horizontal line test. Okay, determine if a graph is 1 to 1. We'll state the domain and range of the graph and its inverse. Let's see. So if I look at this first graph, it's the graph of a line. It's going to pass the vertical line test. It passes the horizontal line test. So yes, we call it 1 to 1. We call a function 1 to 1 if it passes both the vertical and horizontal line tests. Should have a couple more lines here. Let's state the domain and range for both the original f of x and the inverse f inverse of x. So we'll do that on all of these. We'll state the domain and range for the original and for the inverse. Domain and range. The original f of x and the inverse. Domain and range. Okay, domain is how far left, and how far to the right our graph will go. Well, we assume on the end that it will just keep on going. So the domain would be from negative infinity to positive infinity. It goes forever left and forever right. The range is how far down and how far up the graph is going to go. Again, that is from negative infinity to infinity. For a line, it just keeps going forever, both left, right, up, and down. Well, the inverse is going to be the domain and range switched. So the range becomes my domain, negative infinity to infinity. And the domain becomes the range. It's just they're both the domain and range are the same, so on the inverse they're still the same. Okay, this next graph will be the graph of an absolute value function, like the absolute value of x plus something, I don't know. Let's see, plus, we've gone over here. Well, we'll get into absolute values later. For right now, let's just state domain and range, and whether or not it's 1 to 1. It's gonna pass the vertical line test, but it is going to fail. It's going to fail the horizontal line test. So this is not a 1 to 1 function, because its inverse will not be a function. The domain of the original, it goes forever to the left and forever to the right. So the domain is negative infinity to positive infinity. And that will become the range on the inverse. The range is how low does it go. 4 is as low as it gets, and it goes up, up, up forever. So our range is from 4 to infinity, and that will become the domain on our inverse. Okay, this next one is an exponential function, and it will pass the vertical test, and it will pass the horizontal test. So it is 1 to 1. The domain, let's see, it goes forever to the left and forever to the right. Doesn't stop. Range, let's see. Oh, I made a little error here. Let's fix this. Okay, on our previous example with this absolute value, it actually includes the 4. So I should put, just so I remember that I made that little error there, I'm going to put that in black. So I should have a bracket on this 4 because that's part of the range. It actually hits that number. Where over here on this exponential, we have an asymptote at y equals, let's see, is that -6? Y equals -6. And asymptote is a value where the function just gets closer and closer to, but doesn't actually touch. So we say the range is from, let's change my color here. No, not that. Right there. Okay, so my range will be from -6 to infinity. Okay, so the domain up above becomes the range below on the inverse, and the range from the original becomes the domain on the inverse. All right, so let's talk about how to do this with an equation, or the function f of x when it's written in equation form. All right, to find the inverse of a function f of x, we are going to represent that with f inverse of x. Here's the steps to do that. First, we rename f of x to y. We switch x and y, because we've been talking about switching domains and ranges. We solve for y, and then we rename the y to f inverse of x. Okay, on the first example, we're going to follow these steps here. We're going to switch f of x to y. Now we're going to switch x and y, so x equals -4y plus 7. Now we're going to solve for y by taking away 7 on both sides of the equation. So let's see, now we have x minus 7 equals -4y. And to solve for y, we divide by -4 both sides. So let's see, that would give us y equals -1/4 x plus 7/4. And then we rename y back to f of x. So f inverse of x is equal to -1/4 x plus 7/4. Okay, once again, we're going to change f of x to y. We're going to switch x and y. Now solve for y. So I'm going to add 4 to both sides. Okay, so next I need to divide both sides by 2/3. When you divide fractions, it's the same as flipping and multiplying. So I'm going to multiply both sides of the equation by 3/2. So let's see, that will give us 3/2 x plus 4 equals y. Because these fractions will cancel out, I'll get 6/6. When I times 2/3 by 3/2, I'll get 6/6, which is just 1. And then last of all, we switch y back to f inverse of x. So f inverse of x is equal to 3/2 x plus 4. All right, last one. So first step, switch f of x to y. Switch x and y. Now solve for y. I'm going to multiply both sides by 5. Add 7 to both sides. And then divide by 3. So y is equal to 5/3 x plus 7/3. And last of all, we switch y to f inverse of x. All right, let me know if you have any other questions.